Hello everybody, welcome to our video series on using SolidWorks to create engineering drawings. So what we're going to be doing today is actually create our drawings in SolidWorks. So far we've been looking at creating solid models and then using them in our assemblies. So now we're going to be creating the actual drawings that you'd be sending it for production. So here's what we're going to be doing today. So we'll talk a little bit about what engineering drawings are, and then I'll talk about how you'll dimension holes. We'll talk about what are first and third angle projections, and then we'll talk about setting up the drawing canvas in SolidWorks. Generally, what you're doing is when we create the 3D model, you need to actually print it or kind of represent it on 2D scale. So obviously on the screen, you're able to rotate the object and then you're able to make sense of how the object looks. But more generally, if you want to send it out for production, you would actually need to have a standard representation of the part. So this is where our engineering drawing comes in. So these are actually like language, standardized language. So just as in English, if you want to communicate something, you need to have a specific piece of information. Like if I say I sat on the table versus the table sat me, it doesn't really make sense. Same way, the engineering language, you need to have specific symbols and specific order in which the objects are sent. So we need to actually convey and capture all the information that's available, and we need to fully dimension. So think about fully constraining the object. So we need to fully dimension the object. The object itself needs to convey graphics, dimensions, words, and notes. We'll communicate basically the fundamental purpose of dimension. We'll figure out where different parts are located and how different features are related to each other. And we also include notes or text which helps the person who's manufacturing it make it better. The idea is to basically convey the form, fit, and function of the object using just the text. So this is important because when you wanted to document some of the stuff, everything needs to be in 2D print form. So the main thing is if things go wrong, you need to figure out who's to blame. So that's the fun part. So if you have a standardized drawing and you have a missing dimension, then if you go back to the manufacturer of the part, this is mainly useful when you're maybe like outsourcing the part. And if you have all the dimensions in place, then if there is a mistake, so you can trace back through the paper trail and then figure out whose mistake it is and who's going to be liable and who's going to, like whose headache it's going to be. So it's important we learn our language correctly so that we don't miscommunicate any information. When we actually dimension, you're going to be picking the best view for all the dimension. So you pick the view that gives the most amount of information, and then you want to avoid dimensioning on hidden views. You do not give redundant information. So either if you have the same dimension, you don't want to put it in multiple views. And also if one particular dimension can be interpreted as a combination of another dimension, another sets of dimension, you should not include that. So you would, if you really need to include that information, you use something called as a reference dimension. When we're using holes, it is recommended that you use the hole wizard in SolidWorks, and then it makes our life significantly easier. So we're going to kind of do a quick example like so, where we have different features. So these are known as counterbores, countersink, spot faces, and so on. And these are the different symbols. So if you're using SolidWorks hole wizard, all of this gets automatically created for you. Here is where we go. So in order to create a drawing, so we already done the part, the assembly. So now we are going to create a new drawing like so. Since we want to look at a more interesting example, so I've reused the like the shape that I had from last time. So you'll see that shortly now. So I'm going to reuse this particular shape for creating my drawing. So I already have this open. So what we're going to do is I'm going to go Control N. And then here, I've created a few other templates. So you wouldn't obviously have this template. So you would basically click on this drawing and then you would click OK. If you want to scroll through this, so ANSI A is going to be our standard letter shape. So this is in landscape. So this is in portrait. So it gives you the dimension. So this one is actually in meters right now. So you can also kind of like change the value for this. So this one is about 21 centimeters by 28 centimeters. So these are different sizes. So this is obviously smaller. If you're using A4 sheet. If for printing, you can basically select ANSI A4 in landscape or portrait. So since mostly you'll be printing it off a letter sheet for now, I'm going to pick ANSI A landscape. I'm going to have this left panel where I can select all of the open models that are available. Since I have the part open, I'm going to leave that here. If it wasn't open, I can basically click browse and then locate the part, and then I'll be able to include that here. So if we are not going to do this for now, I'm going to show you how we can do it later, but I'm going to show you some of the features that are actually available here. So if you look at this particular sheet, so this actually has a grid available here. So this says A, B, and then 1, 2, because it's a smaller sheet, you don't have too many of the grid points. So this is basically used to kind of map your feature. So you might want to put in your note, you're going to say B1, there is some intrinsic feature, then take care of that particular feature. So right now you notice the bottom here, it says draw 1. So this is the same name as my file name that's being saved. So if I basically save this and then call it video 06, so you can either click on the signal over here or Control B to rebuild the drawing. So now the drawing number is being updated to the file name. So you're going to save it again. You have few other sheets here, and then I'll switch back to my SolidWorks drawing and then show you, switch back to my presentation and then show you what's available. So before we do that, I'm going to talk a little briefly on what's called as first angle and third angle projection. So normally there are two ways in which you can project the object. So if I have this particular sheet like so, I can think of two ways of doing this. I can either have a sheet on the back, which would be here, and then I'm going to project everything onto the sheet, and then I'm going to have another sheet on the top where everything gets projected to the top, and then everything gets projected to the bottom. The other way to do it is you can think of actually viewing this object and then putting the screen in front over here. So think of having a transparent or a translucent sheet. So if I have a transparent sheet like so, and then I have this object, so think of this actually getting projected to the front of the screen, and then I create like some scribbles over here. So this, you can see kind of like a scribble over here. This would be how the object looks. So that's getting projected to the front of the screen. So these are two ways in which you can do this projection, and this is where the two standards differ. So you have something known as the first angle and third angle projection. In the third angle, what is actually happening is the top view goes to the top. So this is the top view. The right view goes to the right, and the front view stays here. The first angle, which is the standard used, known as the ISO standard, which is used in the rest of the world except the United States. Here what happens is you actually, so the ANSI standard is similar to having kind of a transparent sheet over here, and then you're kind of like moving everything to the top. The first angle projection is something that's being actually projected to a screen here. So you have a screen at the back, so all the front thing goes here, and then you have a screen at the bottom where the top view kind of gets projected. So these lines kind of go down, and then you create that view. So you can actually move this part over here, and then that will give you the front and the top view. So I'm going to show you the difference between the two views here. So I'll show you how to switch between the two views, and then I'll show you the difference between the two. So if you go to the sheet properties, I can actually switch between the first angle and the third angle projection. So based on what you chose, the first time you use SolidWorks, your default might be either the first or the third angle. So if you go to SolidWorks here, so I can select model view, and then I'll be able to select just one view, or I can select the standard 3 views for this particular object, and then it's going to create the 3 views over here. I can actually move these, but the views are actually locked related to each other. So the front view is independent to move, so I can kind of move it anywhere I want. The top view, I can only move it this way. I can't move it along the horizontal. And same way, the side view cannot be moved up or down. You can only move this way or that way. So this, if you notice, is actually in the third angle where the top view is to the top and the right view is to the right. So for some reason, my default has been set differently. If you find that the views are messed up, so you need to right click on the properties, and then if it was first angle, so you notice that this actually becomes the bottom view. So I can actually project. Let me actually do all the projections here. So I'm going to select this, I'm going to select projected view, I'm going to put this over here, projected view again. Oops. So this is the view. Let's adjust it to kind of like space it nicely. So now imagine your drawing looks like this. So this is actually the bottom of the sheet. So what I'm going to do is right click, properties, and then if I go from first angle to third angle and then say OK, now notice that the top view is to the top, the right view is to the right, and so on and so forth. So right now if you notice, this view doesn't have any of the hidden lines. So this one is kind of like completely empty, but then you would normally want to have hidden lines for this edge, and so on. So what I need to do is if I click on this particular view, and then I can kind of go down here and then select the way the view is set up. So I want to actually show the hidden lines. So I click on this. The projected views actually get or inherit these properties. So if I didn't want that, I can go back and edit it. So basically I don't want these two views. I can actually click on here and then delete it. Say yes. Say yes, and then kind of like move it in to basically space it properly. Optionally, what you can do is actually save your template. So this is what I've done. So if you notice, my new actually had a ANSI thing show up. So what I would do is basically go here, and then my Control N, I click my drawing, say OK. I'm going to go ANSI landscape. Say OK, and then I'm not going to insert anything here, and then when I go to properties here, sheet properties, I'm going to make sure this is selected to third angle, say OK. If I wanted to change any of the other options or customize this, I can go, if I wanted to change any of the sheet options, I can go here, document properties, ANSI, and then kind of if I wanted to change any of these, you can change those parameters. And then you close it, and then you go File, and then you go Save or Save As, and then you can select Drawing Template over here. So instead of selecting and you're saving it as a drawing, you'll save it as a drawing template. And then if I did that, it basically saves it in SolidWorks template. I already have an ANSI template that I basically saved for myself, and that's why when I do Control N, I have this additional ANSI template that shows up. So my ANSI template here is actually in portrait mode. That is fine. Maybe I can save this as an ANSI landscape. So let's do that. So I'm going to go File, Save As, SolidWorks template. I'm going to go ANSI, and then I'm going to go maybe underscore landscape for ls and say save. And then now if I do Control N, notice that I have an ANSI, and then if I click on this, I have an ANSI landscape, and then if I pull this over, I'm going to get the actual sheet. So we mentioned about the bottom part where the name actually updated. So this is actually known as the title block. So this is useful to basically convey information when things are printed. So if you notice, there are additional information here. So this is the finish here that is used for machining purposes. Then here it says all dimensions are millimeter unless otherwise specified. And then here you have something called as drawn by, signature, so on and so forth. So this is mainly useful when you're doing like a production drawing, and then people are actually going to want to figure out, have a paper trail to figure out who actually created the drawing, and then who actually checked to make sure everything is up to code, you haven't missed or anything, you haven't made a mistake. Because if you imagine you're sending this out for manufacturing, say to China, and then after a month you get the part and then you notice one dimension is off, then you need to figure out what the problem is or where the problem is. and then who needs to kind of correct this and kind of go through the problem and then make sure everything is up to code or whatever is needed. So if you wanted to include the other properties, what you do is you go to File, Properties, and then you can use the drop down menu in the custom to select Drawn By, enter the text, and then whatever is entered here, the drawn by and the date is shown. So let's show how that works. So here is my SolidWorks. So here if you wanted to populate the rest of it, so let's zoom in here. So here is where all the templates are. It says all dimensions are in inches because my units here. I selected an ANSI here. I would need to basically manually edit this template. So I can actually go edit sheet format. And then here I can actually edit this text. So I'm going to make from inches to millimeters. And then save. And then what I'm going to do is I'm going to click this, which basically closes the sheet format. And then I'm going to go File, Properties. And then here is the sheet format. And then I'm going to click here and then say Drawn By. So you're going to go Drawn By. So this is going to be a text. I'm going to put my name. And then I'm going to have Drawn By date. So I'm going to say today rather than today. I'm going to go put some date here. So today is, just pick some number. So August 17th, 2016. And then you can have other pieces of information if you needed to. So you might have like the part number, revision, like if you make cost, like the material, lead time, so on and so forth. And then when you say OK, this gets populated here. So if I see that the space isn't enough, I might have to actually go back and edit the sheet format. So this date is too long, right? Maybe I should just use numeric format. So I'm going to basically go again, edit properties. And the date, I can basically say 17 8 2016 or something, and then save this. So the things here can be populated as well. So you can actually insert, like when you go to sheet format, you can manually enter in some of the values that are actually missing here. Now let's actually go ahead and dimension this particular part. So this, if you look at this part, I'm going to start with the front view. So maybe move it to a nicer location. And then we go to annotation. Again, we have the smart dimension. So I would probably need like the overall width. So I'm going to basically go, maybe I want to dimension this and then this. So I'm going to go click here. This is 10. Let's say I want to click here and here. And then this is going to be 50. So what I shouldn't do is I shouldn't go here and here and then dimension. So SolidWorks will still let me do this, but then notice one of the rules is you don't want to have redundant dimension. So I don't want, so I can basically interpret this to be 50 by adding this 10 with this 40 would give me 50. So I don't want to use that information. So I need to include only 2 of these 3. If I really wanted to include this 40, or I wanted to include all 3, so what I need to do is make this a reference dimension. So I'll go is click on this and say add parentheses. So this is kind of the standard symbol for making a reference dimension, and then I can move it out of the way here. Save. The other thing I would want to avoid is kind of using lines kind of through the text. So I'm going to leave it as is. Kind of move this here, move this here. So if I wanted to change the arrow format, I could potentially do this. So this kind of changes the location of the arrow. This one we're going to leave it here. So I'm still not completely defined my object. So I would need to figure out this is done. This is the dimension of the ledge. I would probably want to dimension this. So this isn't very useful. So what I would need to do is kind of dimension this ledge here. So this is one feature here Now I notice that these dimensions are crossing each other. So this is not very nice. So I'm going to get rid of this. So notice that I could have dimensioned here. So this would kind of be perfectly okay. So if I didn't have this 20, I'm perfectly okay to kind of dimension here and then call this 10. So this is completely valid. But then if I look at the actual object, my 3D shape, what I've actually dimensioned is this little kink part here. This is not very useful. What might be more useful is kind of the total width of the top face. So what I'm going to do is not dimension this part, this ledge. So I'm going to delete this and rather dimension the whole entire top portion. So I'm going to click here, smart dimension, click here, and then call this 20. What might be useful is kind of getting the overall length of this part, or what I can do is give you the overall dimension of the full part, in which case I wouldn't have the parentheses here, and then save it. So if you look at this view, I've gotten all the information that I would need. So now things are missing is in the vertical, so I'll give the total height here, and then I'm going to give this height, which is going to be 20, and then I'm going to give the height of this ledge, and then save. So unfortunately, unlike the sketch, here what needs to happen is you need to manually verify that you have provided all piece of information to completely construct the front view. So I look at this and say, okay, I can figure out the overall size of the part. So this is going to be 30 by 50, that's good. Can I figure out how wide the top part is? I have this 20. Can I figure out this dimension? So this is going to be 50 minus 20, so this 30, that's good. I know this part, this is 10. This height of this ledge is going to be 10 from here. This line is going to be at 20. This one is 30, so I can figure out the overall, all the parameters. Next, I'm going to look at the side view. So I'm going to go this. I'm going to give the overall depth, which is going to be 40. And I'm going to give for the slope, I can pick different values. So I can either give this part the depth. So I'm going to give this here, which is 10. That's one way to do it. Alternately, what I can do is I can give this angle. So I'm going to go for smart, still on smart dimensions. I'll click this line and then this line and then give the angle over here. Either one of it will be perfectly acceptable, but then since I was constructing this to be 10 millimeters wide, so I'm going to go give that dimension. So notice that I'm not giving any of the vertical dimensions. So if I wanted to figure out where this ledge is, I would actually refer to the perpendicular view, the front view. So here, since this edge is aligned here, and then this is at 20 to the bottom, I already know where this is located. I know the total width or the total depth here. And then if I wanted to figure out where this edge ends, I'm going to refer to this view. And then I find out this is at 10, so I already know that. Notice that I'm not giving this height because it gets interpreted based on where the intersection lies. So this height here is kind of interpreted where kind of this line and this line meet. So this is interpreted, so I don't actually give that value either. Save. This particular drawing doesn't have any holes, so we're going to create a simple part with several holes and then see how to use hole callout now. I go Control N. I'm going to create a new part. This, for simplicity, I'm just going to create a rectangular part. So I'm going to make it say 50 by 50 or 50 by 100. So in order to create the holes, what I'm going to do is actually offset this rectangle inward. So I'm going to click Offset Curve, and then I'm going to click this, and then now it's going outward, so I'm going to flip. So if I say add going inward, and then I'm going to say OK. This actually creates a curve here, and then I'm going to select all of these lines and then make them for construction. And save, exit, and then what I'm going to do is extrude downwards and then extrude it for say 50 millimeters. Say okay, save it again. So I'm going to create my hole using hole wizard, so I need to make my sketch visible first. So I'm going to use hole wizard, and then we're going to create different holes here. Oops. So you can move through here. This is called a counter bore. So I'm going to make one counter bore hole here in this location. So here you can select different combinations. So I'm going to select ANSI metric, and then let's make it a 10 millimeter M10. So here I go to this and then say I'm going to put it here. So I need to click on this plane, and then this hole is too large. That's okay. So you're going to leave it as is. Say okay. So we notice the hole is starting to look a little weird. So the reason for it is the depth is really small. So I'm going to basically go here and then change it to say 30 millimeters deep. And then I say okay, now I have the proper counter bore shape here. So I go Control 7 to get an isometric view again. I'm going to create a different type of hole here. So I'm going to go hole wizard. Let's create it a counter sink. So at this location, so I'm going to go again, same thing, position here on this plane here, and then say okay, this is done. So the depth is really small, so you can kind of fix it again. So edit properties, figure out how deep you want to go. So let's make it 30 millimeters. Say okay. Again, hole wizard, so you can play around with all of these, see what the different options are. This is a slot, so this is a countersink slot. This is a tap hole, so you have a legacy hole. This is a normal hole. This is threaded. So just for the fun of it, let's do a threaded tap here. So again, this is also M5. Say okay. So again, if I wanted to see the actual holes, so I need to go options, and then we need to click document properties, detailing, and then show cosmetic thread. So now my thread is actually shown. So we'll save this, and then I go Control N. I'm going to click my ANSI landscape, say okay. Here I'm going to make this as millimeters. And then I'm going to insert my sketch. So view layout, model view. I'm going to pick only the top. And then say okay. So the reason is I'm only going to show how the whole thing works, the whole wizard, how useful it is. The rest of it, you can include the front view and then see how it looks. So you notice that this triangle is being shown. So I can hide it in one of two ways. So I can either go here and then on this sketch, I can hide the sketch, or I can go back to the drawing here and then hide the sketch again. So what I'm going to do is use the hole callout wizard, which is located here. So here, if I click on this hole, so it'll kind of calculate the standard values for different hole features. So this is basically the diameter was 10, the depth was 30, the whole thing was 20. And then this again, it tells you what the different parameters are. So this allows you to automatically quickly create the whole feature and then use the hole callout wizard really quickly. So this basically concludes the first part of the drawing tutorial, and thank you for watching it.